In this video, we will discuss about the smart grid information layer. So let's see what are the various components which are there in the information layer. This is a particular architecture which you will see at the control center where the information is being processed. So in the field, you will have multiple data processing devices, say conventional field devices such as the current transformers, potential transformers, or maybe the intelligent electronic devices, or maybe the remote terminal units and so on. So in the field, you will have various data acquisition devices which will send data at the control center. At control center, you will have a real-time high-speed service bus. That is basically the uh, local area network which will communicate data at very fast rate. So this data will be shared by various operational technology applications such as SCADA, network management, outage management, historian, or maybe planning applications. So all these applications fall under operational technology. So the initial layer at the control center will comprise of operational technology applications where the data comes from the field and accordingly it is being shared by the operational technology applications. Now the information also needs to be processed by various information technology applications, but this data cannot be shared directly with the information technology applications such as customer information system, enterprise resource planning, or the GIS, enterprise asset management, advanced meeting infrastructure, or maybe the market applications. Since these applications are mostly the information technology related applications, their data formatting and the access points through which they will access the data will be entirely different when you compare with the operational technology applications. So the requirement is to convert this data into a format which can be easily consumed by the information technology applications. So what will happen that the data will travel across the enterprise service bus where various enterprise applications will be hosted and will share the data which will be given by the operational technology applications. Now, since the data format of the applications which are there at the OT level are different from that in the IT level, the data conversion needs to happen. How it will happen, we'll see in the next slide. One more important thing to mention here is that the such kind of architecture is applicable not only for electricity but also for gas and water related applications share such kind of information architecture at the control center. So when we talk about the smart city architecture where electricity, gas and water all are integrated, these kind of architectures are being utilized. Now let's see the challenge which we face in integrating the various applications and how we address the challenge in the integration of various applications and the data sharing in the standard format. So let's understand that also. So at the field level, the data is being sent over communication medium to the control center. So at the control center, we will have the communication front end which will receive the data, or maybe the data can come from alternate substation where we use inter control center communication protocol. So this layer is nothing but real-time data collection and processing layer, where the communication front ender will receive the data, filter out the initial data set, and then this will share the data to high-speed service bus. So this is the high-speed service bus where all the operational technology applications will send and receive the data. Now the problem is that the various devices which share data with the control center from the field, they might be having different data types and the data formats. So if the data is not in a standardized format, the communication of data and the information sharing will not be an easy task. So what to do? The communication front-ending application will have another plugin which is called as high-speed service bus adapter, which will convert non-standard data formats into a standard data format. So the non-standard data which is being received from the field will be first converted into a standard data format using HSP adapter. So adapter is nothing but one small software application which will convert non-standard data into a standard data type. So the advantage of having this adapter is to share the data seamlessly with the other software applications. Similarly, for ICCP also, the non-standard data format will be converted into a standard data format, and that will be shared with the high-speed service bus. Now, the data which is traveling in this high-speed service bus is a standard data. So in that case, if any application which is adopting the standard data communication mechanism will consume data directly without having any high-speed bus adapter, because it is already a standard data format, the data will be directly consumed by the application. But right now in the control center, we generally have the applications which are legacy applications. They cannot understand the standard data formats, so they need to add the various adapters so that the standard data format can again be converted into our data format which that application can understand. So what will happen in that case? The applications such as SCADA or automatic generation control or HIS or the TNA or other applications, they will consume the data by converting the standard data format into a local data format, and then the information is processed and shared with the enterprise service bus. Now enterprise service bus is again similar to high speed service bus. The only change is that high speed service bus is mainly supplying the information to the OT, operational technology applications, and the data sharing is very fast. So this bus and as well as the enterprise service bus both will have the standard data format for the consumption by various applications. So now again the problem will be that since these applications like AGC, HIS, TNA and so on have the data being processed in a local data format and the output is also generated in a local data format, then in that case the information has to be converted again in a standard format so that this can be shared with the enterprise service bus. So you need another adapter which is called a SOA adapter. SOA stands for service oriented architecture. So service oriented architecture is web service based technology where the software modules are implemented as a service, That means they will be invoked when you call them. So I would suggest you read the basics of service oriented architecture, and at the same time I would suggest to study the object oriented programming, because until unless you understand object oriented programming, you will not be able to understand the service oriented architecture also. So in that case, the request and response, that is the data sending and receiving, are implemented in the form of web services, and those services are being called whenever the data sharing is required. So all those software applications will create another small plugin, which is nothing but a service oriented architecture adapter, which will convert the local data format which you need to report to other software applications in a standard data format. So now these applications will again convert non-standard data format into a standard data format to be shared by the enterprise service bus. Now this enterprise service bus will share the data with other software applications like model and display management, or maybe scheduling, market management, or participant market management, and so on. So wherever we have the software applications which are the legacy applications and are not having the service oriented architecture based software solutions, the SOA adapter is required, so that the standard data format which is traveling across the enterprise service bus can be consumed by those applications. Now the advantage of having enterprise service bus based standard data communication mechanism is that the application which is following the ESB based software architecture can directly consume the data without implementing the SOA adapter, because it knows that how to consume the standard data. So the standard IT applications such as customer information system, or maybe the SOA based billing applications or other applications, will directly consume the data which is being shared in the enterprise service bus. So until you have the solution developed keeping in mind the SOA architecture, the plugin is always required to convert the standard data format into a local data format for the consumption by that application. So the smart grid service oriented architecture model is required for information sharing in those cases where the data generated by the applications are not in a standard data format. The important thing to keep in mind is that until unless you implement the data adapters to convert the non-standard data into standard data formats, the seamless data exchange is not possible. Now let's see the smart grid model for information exchange. That means what kind of protocols are being utilized in a complete software solution in case of smart grid and various power system applications. So this smart grid model for information exchange is documented as IEC 62357. So if you go to the website of IEC, that is International Electrotechnical Commission, and you search IEC 62357, you will get this figure which demonstrates the various protocols implemented at different layers. So let's try to understand what the various protocol means and where we are using them. So at the base we will have intelligent electronic devices, relays, meters, and the current as well as potential transformers. So these are the devices which are sensor or the data acquisition devices deployed in the field to acquire the required power system data. So required power system data means you need to acquire the status of the breakers, you need to acquire the voltage, current, power factor, real reactive power, and so on. So all those informations which you want to get from the field will be taken by these devices, because these are eyes and ears of the power system network. Now these devices will send data via a communication mechanism to the information layer. So say for example, the substation devices such as intelligent electronic devices or maybe relays, they will utilize IEC 61850 protocol for binding the data. So that means the data which you generate at the field will be packed into a data frame suggested by IEC 61850 protocol. Similarly, for RTU data communication, because remote terminal unit is also a data acquisition device, for SCADA communication, they utilize various SCADA communication protocol which are documented in IEC 60870-5. So the data which comes from the field to RTU will pack that data into a frames suggested by various IEC 60870-5 protocols, and the data packet is shared with the communication front-ending layer of the control center. For smart meter, we are utilizing IS 16444 in India, and the communication protocol is IEC 62056. So we will study this protocol when we will talk about the smart meter as a measurement device. So we'll discuss them in detail when we go through those devices in detail. For others, like if you want to share data from computer to the control center, you can use XML based messaging systems, which are standard IT application based messaging system for sharing the data. And we can also use the 60870-6, that is inter-control center communication protocol, that we will discuss along with the 60870-5 for better understanding. Now we need multiple communication mechanism. So the legacy protocols, that is telecontrol protocols, are there where we use generally in SCADA communication. So those are documented as IEC 60495, 663 and 834. Other than that, various the wired as well as wireless communication services are available, through which the data travels to communication front-ending applications at the control center. There the information is processed, and the processed data is shared with the data acquisition and control front end, which makes sure that the data is securely communicated from the various devices, and then this data is shared with various software applications. So now the data acquisition happened at the control center using communication front-ending application, or using gateways, or maybe proxy server or other mapping services which are required to receive the data from the field and then communicate to the various functional applications such as SCADA, EMS, DMS, maybe marketing operation applications, or the external IT applications. Now, these are the functional applications which receive data directly from the field, and it is the output of these application is not in a standard format, which can be directly consumed by IT applications, because these are the OT applications, and the data format followed by these applications are entirely different from the data format of IT applications. So we need the data to be transformed into a standard data formats. Say IC 61970, 61968 are the common information model standard. So the data format, which is non-standard, will be changed into a standard format using the 61970 and 61968 standard suggested in common information model based standard. And this standard based data will be now flowing in the enterprise service bus. And then this data will be consumed by various other IT applications or the other business related applications for further processing of the data, and then the refined data will be displayed to the external world. For communicating the data, the end-to-end security is also required, where lot of security measures are taken by the various software applications, and we will discuss them when we will go through the various protocols, so that you can understand how to secure the data and send that data to the control centers.